The models are not exaggerating. The data is not lying. Right now, as of this morning, June 20th, the United States is being hit from 3 directions at once, and not one of those directions is giving ground. A dangerous heat dome is suffocating more than 170 million Americans from the plains to the East Coast, with temperatures approaching and exceeding 100 degrees across more than 36 states. A deadly severe weather outbreak is already firing across Kansas and Nebraska today, with the Storm Prediction Center issuing an enhanced risk, level 3 out of 5, for tornadoes, damaging winds, and very large hail. And in the Deep South, the remnants of Tropical Storm Arthur are still draining floodwaters from Texas to Georgia after dumping over a foot of rain across communities already reeling from a catastrophic start to hurricane season. 3 systems, 1 country, 1 weekend. And that is before I show you what the long-range data says about where all of this is heading, because the driving force behind every single one of these events is the same engine, and it is accelerating. That engine is a developing Super El Nino, and what the European Centre for Medium-Range Weather Forecasts and NOAA are now projecting for the months ahead should have every American paying close attention. Here is what we are covering today. The severe weather outbreak unfolding right now across the Central Plains, the heat dome scorching the eastern half of the country and how long it stays, the complete rundown on Tropical Storm Arthur and what the flood threat looks like going into next week, and then the big picture, the Super El Nino signal that is rewriting this entire summer forecast. Let's get into the data. I am Arthur, and welcome to Sky Space Lab. If you are new here, this channel exists for one reason: to give you the most accurate data-driven weather science available in plain language. No hype without numbers, no threats without sourcing. Every single claim in this video traces back to a real agency or a real model run. If that is the kind of weather coverage you want, hit subscribe and turn on notifications. You will never miss a critical update. Let's get into the data. Today's severe weather threat is real, it is active, and it is targeting some of the most tornado-favorable territory in the entire country. The Storm Prediction Center in Norman, Oklahoma issued an enhanced risk, that is level 3 out of 5 on the severity scale, for portions of Kansas and Nebraska specifically for today, Saturday, June 20th. This is not a marginal risk. This is not a slight risk. Level 3 means organized, long-track supercells are on the table, and the conditions backing that assessment are significant. Here is what is happening in the atmosphere. A surface low-pressure system is deepening across eastern Colorado today. That system is driving a frontal boundary eastward into central and southern Nebraska, while a dry line, a sharp moisture boundary, extends southward into the southern plains. As the low deepens through the afternoon, low-level flow is strengthening, and that is transporting rich moisture northward from the south, directly into Kansas, northeast Colorado, and southwest Nebraska. The Storm Prediction Center is explicit. By mid-afternoon today, storms will develop within the upslope flow across eastern Wyoming, southwest South Dakota, and the Nebraska Panhandle. By later in the afternoon, expect storms to erupt along the uncapped dry line across eastern Colorado and western Kansas, and along that frontal zone across central and southern Nebraska. Here is who needs to watch this the most. If you are in Salina, Hutchinson, Wichita, Great Bend, or Dodge City in Kansas, you are in the bullseye. If you're in Hastings, Kearney, Lexington, North Platte, or along the Interstate 80 corridor in south-central Nebraska, you're in the enhanced risk zone. If you're in Colby, Kansas, or Goodland, Kansas, you're on the edge of the primary threat area. The initial supercells firing along that dry line will pose a threat for large to very large hail. Hail sizes of 2 inches in diameter, that is baseball size, are expected to be possible in the most significant supercells. The National Weather Service Forecast Office in Hastings has confirmed that tornado potential will increase, particularly along the frontal boundary and as the low-level jet strengthens during the evening hours. Damaging winds exceeding 75 miles per hour are forecast. Here is where it gets more dangerous. The Storm Prediction Center is warning that these initial supercells are expected to congeal into one or more mesoscale convective systems, large organized storm complexes, during the evening hours and then track southeastward into central and eastern Kansas. When that transition happens, the primary threat shifts toward destructive straight-line winds, potentially reaching 75 miles per hour or higher. There is also a spin-up tornado threat embedded within any quasi-linear convective system that develops. Where are you in all of this? Drop a comment right now. Tell me your city and state. If you are under this threat today, I want to know you are watching. This is not the end of the severe weather story this week. The same surface low that is driving today's outbreak will slowly progress east. The Storm Prediction Center's Day 4 through 8 outlook, issued on June 19th, noted that severe weather is possible along a frontal zone from the mid-Atlantic to the southern plains on Monday. The specific threat areas are still resolving, but shortwave energy embedded in broader cyclonic flow will continue to provide severe weather opportunities as we go into the work week. Tuesday is another day to watch across the central high plains. The energy does not die quietly. It keeps driving systems east, reloading moisture return and producing new threats. If you are in the Midwest, Iowa, Illinois, Indiana, Missouri, keep your weather awareness elevated through the coming days. Now, I want to talk about the heat, because the temperature picture on top of this severe weather threat is extraordinary. 170 million Americans. That is the number AccuWeather is putting on the heat dome impacting the central and eastern United States right now. The National Weather Service has issued widespread dangerous heat warnings, with heat index values forecast as high as 110 degrees in parts of Texas. The NWS confirmed in a recent statement that extremely dangerous heat will persist from the Midwest to the East Coast with numerous daily record highs and very warm overnight lows expected. The overnight temperature problem is the part that most people are not fully grasping. When daytime temperatures hit the mid-90s to 100 degrees, and then overnight lows only drop to the upper 70s or low 80s, your body gets no physiological reset. You go into the next day already heat-stressed. That is when heat-related illness and death rates climb sharply. The NWS specifically flagged the Ohio Valley, the eastern Great Lakes, the interior South, and much of the East Coast as areas of particular concern for persistent heat. Washington, D.C., Baltimore, Philadelphia, and New York. All of these cities are forecast to see temperatures very close to or exceeding 100 degrees during the peak of this heat event. AccuWeather's real field temperature values, which account for humidity, sun angle, and wind, are peaking above 100 degrees for millions of people across more than 36 states. NOAA confirmed in May that March 2026 was the hottest March ever recorded across the contiguous United States. The country just wrapped up its warmest 12-month stretch on record. This heat dome did not come from nowhere. It is built on an atmospheric foundation that has been warming consistently for over a year. So when does relief come? That is the question I get most often in situations like this. The short answer is not soon. The heat dome pattern is being reinforced by the very same omega blocking configuration that has been driving severe weather across the plains. A ridge is parked over the eastern and central United States, suppressing storm activity in the east while funneling energy along its flanks. Breaking that ridge requires either a significant trough from the west to dig aggressively into the pattern, or the jet stream to buckle in a way that undercuts the high pressure. Right now, the updated model guidance is not showing a rapid breakdown of this heat event. Expect the heat dome to remain in place and potentially expand through next week. If you have elderly family members, young children, or pets, please take this seriously today. Heat kills more Americans each year than hurricanes, floods, and tornadoes combined. This is not a comfortable statistic. It is a life safety statement. Most channels are not showing you this part, but it matters. The heat dome and the severe weather are not separate events. They are part of the same atmospheric architecture. The ridge causing your heat is also the boundary where the jet stream is being kinked, and that kink is where the severe thunderstorm energy is concentrating. You do not get one without the other in this pattern. Let me walk you through the 7-day picture day by day so you know exactly what to expect. Today, Saturday, June 20th. Enhanced risk severe weather Kansas and Nebraska. Heat dome at or near peak intensity across the eastern and central United States. Tropical storm moisture still rotating through the Gulf states from Arthur's remnants. Sunday, June 21st. The severe weather threat does not disappear. Scattered storms are expected to develop across western Kansas, eastern Colorado, and southwest Nebraska on Sunday afternoon and evening, triggered by a shortwave trough overspreading the region. The heat remains locked in place across the central and eastern United States. Overnight lows in many cities will stay above 80 degrees, Monday, June 22nd. The updated Storm Prediction Center Day 4 through 8 outlook flags a potential severe weather threat along a frontal zone stretching from the mid-Atlantic to the southern plains. Exact threat areas are still being resolved, but energy will continue pushing through the system. The heat dome continues. Tuesday, June 23rd, another potential severe weather day across the central high plains. The confluence of returning moisture and embedded shortwave energy continues to drive convective opportunities. Flash flooding concerns persist in areas still saturated from Arthur's passage. Wednesday, June 24th. Models are beginning to show some potential for a pattern disruption signal by midweek, but confidence in the timing and magnitude is still low. The ECM, WF and GFS are not fully in agreement on the evolution of the western ridge. Any cooling in the east will lag the storm track by at least 2 to 3 days. Thursday, June 25th through Saturday, June 27th. The AccuWeather Summer Outlook, along with NOAA CPC's June to August seasonal forecast, both project above-average temperatures to persist across most of the country. The summer of 2026 is shaping up to be a sustained warmth event, not a brief episode. But here is where it gets really interesting, and I will show you exactly why in just a moment. Before I get to the big picture, I want to give you the full rundown on Tropical Storm Arthur, because what happened this week is the opening chapter of what this summer is going to look like along the Gulf Coast and through the Deep South. On June 16th, the National Hurricane Center designated a sprawling area of disturbed weather, churning in the northwest Gulf as potential Tropical Cyclone 1. By June 17th at 11 in the morning Eastern Time, Hurricane Hunter aircraft confirmed a defined surface circulation and sustained winds of 40 miles per hour. Potential Tropical Cyclone 1 officially became Tropical Storm Arthur, the first named storm of the 2026 Atlantic hurricane season. The system's track kept it grinding along the upper Texas coast, drawing on warm Gulf waters before turning inland over southwestern Louisiana on June 17th into the 18th. The National Hurricane Center issued a tropical storm warning from Sargent, Texas, eastward to Morgan City, Louisiana. Tropical storm warnings represent a serious threat, sustained tropical storm force winds within the warned area. But here is the critical piece of information that got lost in some of the coverage. The wind was not Arthur's primary danger, the rain was, and the rain was catastrophic. The National Hurricane Center forecasted 5 to 10 inches of rain across Texas, Louisiana, Mississippi, and Alabama, with isolated totals near 20 inches. Not 5 inches, not 10 inches, 20 inches in localized areas. Over a foot of rain fell across parts of the impact zone within a 24-hour period, according to Louisiana Governor Jeff Landry's emergency declaration. That declaration covered the entire state of Louisiana. Texas Governor Greg Abbott issued a state of emergency for 101 counties, essentially most of Texas, and ordered the Texas Division of Emergency Management to activate around-the-clock operations. The city of Waco recorded significant rainfall from Arthur's precursor system. Brazoria County southwest of Houston saw water surrounding homes. On Interstate 59 in Mississippi, rain left the highway submerged in over a foot of water. A dam on Anchor Lake in Mississippi presented a threat of failing, prompting evacuations of 30 homes. In Alabama, over 20,000 customers lost power, primarily in Mobile County. Flash flooding occurred across portions of Alabama State Route 198. In Georgia, over 4,800 customers lost power, and several FIFA World Cup fan festivals were cancelled due to severe weather. 56 million Americans were under flooding threats at the peak of Arthur's impact. The updated storm track from the National Hurricane Center had Arthur's remnants pushing northeast across the southeastern United States through Thursday and Friday, crossing Georgia, the Carolinas, and continuing northeast. The rain shield extended far inland, well beyond the immediate coast. The NHC explicitly warned that life-threatening flooding would continue in parts of the region, even as Arthur weakened over land. Here is the question you should be asking. If Tropical Storm Arthur formed in mid-June, before the traditional peak of hurricane season, and already triggered state of emergency declarations in Texas, Louisiana, and Mississippi, and sent flood warnings as far as Georgia, what does this tell us about what the rest of the season looks like? That brings me to the big picture, and this is the most important part of this video. The latest model runs just came in, and what they are showing about the rest of this summer is something I have not seen in years. Let's go back to the engine driving all of this, because it explains the heat dome, it explains the severe weather pattern, and it explains why Arthur formed so early and with such a devastating rainfall footprint. El Niño, and not just any El Niño. The the World Meteorological Organization published an update with an 80% likelihood of El Niño conditions persisting through June to August 2026. NOAA's Climate Prediction Center is forecasting above-average temperatures for most of the United States through the summer, with above-average precipitation for portions of the East Coast and the Southwest. But the number that is capturing serious attention from climate scientists and meteorologists alike is this. NOAA has assigned a 37% chance that this event could develop into a very strong El Niño, what some are calling a super El Niño event. The European Centre for Medium-Range Weather Forecast's seasonal forecast is even more aggressive. ECMWF model ensemble runs are placing the Niño 3.4 sea surface temperature anomaly above +2 degrees Celsius across the entire ENSO monitoring region, a remarkable anomaly already in the summer season. Some individual ECMWF ensemble members are exceeding +4 degrees Celsius. To put that in historical context, values of +4 degrees Celsius in the Niño 3.4 region have never been observed in the modern instrumental record. If those outlier runs verify, we're talking about the strongest El Niño event in the history of modern meteorology. The North American Multimodal Ensemble, NOAA's CFS-V2, and the ECMWF all favor strong El Niño development continuing through midsummer. The ECMWF median run for the autumn is already reaching roughly +3 degrees Celsius in the Niño 3.4 region. What does this mean in practical terms? Here is how it connects directly to your weather. El Niño enhances the subtropical jet stream across the southern United States. That is the same jet stream mechanism that is already pumping moisture into the Gulf states and the Midwest. When the subtropical jet is enhanced and active, you get more frequent and more intense convective systems moving across the southern tier of the country, more Gulf moisture transport, and heightened flash flood risk across Texas, Louisiana, Mississippi, Alabama, and Georgia, exactly the states Arthur just hammered. AccuWeather's summer forecast released this season specifically flagged the scenario we are now living inside. Severe weather expected to be most active in June and July from the plains to the Midwest and the Ohio Valley. The hottest weather compared to average focusing on the west and northwest. Flash flood events expected in parts of the plains, the Mississippi Valley, and the Ohio Valley at higher frequency this summer. What about the derecho risk? A derecho, a large, fast-moving line of storms with widespread damaging winds covering hundreds of miles in 12 to 24 hours, is one of the most underrated hazards of summer. If you are in South Dakota, Iowa, Missouri, Illinois, Indiana, or eastern Nebraska, you are in what multiple long-range forecast sources are calling the primary derecho corridor for summer 2026. That threat begins now and extends through the summer. What does a developing super El Niño mean for the Atlantic hurricane season? This is the counterintuitive piece. El Niño typically increases wind shear across the Atlantic's main development region, the stretch of ocean between the Lesser Antilles and the coast of Africa, which suppresses tropical cyclone formation and intensity. NOAA's official Atlantic outlook issued earlier this season forecast a below-normal hurricane season, expecting between 8 and 14 named storms, 3 to 6 hurricanes, and 1 to 3 major hurricanes, with a 55% chance of below-normal activity. But here is the nuance that most coverage misses. El Niño suppresses the deep Atlantic. It does not suppress the Gulf or the Western Caribbean in the same way. The Gulf waters are anomalously warm right now. Arthur exploited exactly that. The Western Caribbean and the Gulf remain vulnerable to early season and mid-season systems, precisely because El Niño's suppression mechanism works differently in the Western Basin. Updated just this morning, NOAA's latest sea surface temperature analysis confirms that water temperatures across the Gulf Basin and into the Western Caribbean remain above average. You do not need a hurricane track-worthy system to cause catastrophic flooding. Arthur proved that. A system that stays just below hurricane strength but carries 20 inches of rain is every bit as dangerous, sometimes more, because it moves slowly. The Atlantic's first named storm, Arthur, formed on June 17th. The median date of first named storm formation in recent decades is June 18th. Arthur was right on schedule, and it did not need to be a major hurricane to cause major damage. So when GFS and Euro agree on something like this, you pay attention. Both models are in agreement on the continued El Niño intensification signal through the summer. Both models are showing that the pattern driving heat, severe weather, and Gulf flooding is not a short-lived event. It is a summer-long regime. Here is a question I want you to answer in the comments below. What is the biggest weather threat where you live right now? The heat, the severe storms, or flooding? Tell me your city and state. I read every single comment on this channel. Before we wrap up, there is one more thing you need to know, and this is the part I have been building toward. I want to zoom out to the largest possible scale, because the 2026 Super El Niño signal is not just a domestic weather story. It is a global atmospheric restructuring event, and understanding it changes how you interpret every single forecast you will hear this summer. The Severe Weather Europe analysis published this week, drawing on the ECMWF, NOAA, and the Australian Bureau of Meteorology, describes what is happening in the subsurface ocean temperatures across the equatorial Pacific as a major atmospheric change that is beginning. The values of oceanic warming already exceed +2 degrees Celsius across the entire ENSO monitoring region. That is remarkable because El Niño events typically peak in boreal winter, November through January, not in June. Having this level of anomaly already present in midsummer means this event has runway. It has months of continued intensification still ahead. The IRI, International Research Institute for Climate and Society at Columbia University, concurs. Their multi-model ensemble is consistent with a moderate to strong event developing, with individual members pushing towards Super El Niño thresholds. What does historical precedent tell us about strong El Niño summers in the United States? A few consistent signals emerge. The southern jet stream becomes more active, which means more storm systems moving across Texas, the Gulf states, and up the East Coast. The Great Basin and the desert southwest trend hotter and drier. Fire weather risk increases significantly across the Pacific Northwest and Northern California, where snowpack is already well below average. Multiple consecutive drought emergency declarations have been issued across Washington state. The northern tier, the Dakotas, Montana, Minnesota, can see volatile swings between heat and severe weather outbreaks as the jet stream buckles along the boundary between the ridge and the incoming troughs. The CPC June to August 2026 seasonal outlook is explicit. Above average temperatures for most of the United States. Above average precipitation for portions of the East Coast and the Southwest. That combination, heat plus rain, is the signature of the enhanced subtropical jet working in combination with a heat dome parked over the central and eastern country. Every major El Niño event in the historical record has an inflection point. It is the moment when the subsurface ocean heat that has been building for months finally couples fully with the atmosphere above it. That coupling is the mechanism that turns a moderate El Niño signal into something the entire jet stream pattern responds to. And based on the latest subsurface ocean temperature analysis from NOAA's Pacific Marine Environmental Laboratory, the warm water anomaly extending along the equatorial Pacific is currently deeper and broader than at comparable points in the 1997-98 event, which was itself one of the strongest El Niños of the 20th century. The 1997-98 Super El Niño brought devastating flooding to California, historic drought to Indonesia and Australia, and amplified severe weather across the southern United States. The current development is tracking at anomalies that are, in some ensemble members, projected to exceed that event. That is the scenario driving the most aggressive ECMWF ensemble members toward the +4 degrees Celsius range. I want to be clear about forecast uncertainty here. Individual ensemble members pushing to extremes do not mean the extreme scenario is guaranteed. Weather science requires probability thinking, not certainty thinking, but when the median ECMWF run is already at +3 degrees Celsius in the Niño 3.4 region, and the median is what agencies base their outlooks on, that is not an extreme outlier. That is the central forecast, and a median forecast of +3 degrees Celsius for autumn is itself a very strong El Niño by any historical standard. What does this mean for the drought picture? NOAA's spring outlook already highlighted ongoing dryness continuing in the west. Washington state has declared drought emergencies for 4 consecutive years. The Pacific Northwest is going into summer, with snowpack running at roughly 50% of normal in several basins. That is critical because low snowpack means earlier runoff, drier soils by July, and dramatically elevated wildfire risk through the late summer and fall. Early melt has already been documented in multiple Pacific Northwest river basins. The National Interagency Fire Center and CAL FIRE both have elevated preparedness levels heading into the peak fire season window. Meanwhile, the southern United States is facing the opposite problem. Too much water in too short a time. The same subtropical jet enhancement that is fueling derecho risk and flash flood potential across the Midwest and the Ohio Valley is pumping anomalous moisture into the Gulf states. Areas still processing Arthur's flooding face the prospect of additional heavy rainfall events as the pattern remains active. There is one more layer I need to add to this picture, and it concerns the interplay between this El Niño development and overnight temperatures. NOAA confirmed that March 2026 was the hottest March ever recorded in the contiguous United States. The last 12 months are the warmest 12-month stretch on record globally. El Niño typically adds 0.1 to 0.2 degrees Celsius on top of the existing background warming trend. When the background trend is already at record levels, and you add a developing super El Niño on top of it, you get a compounding effect. That compounding is showing up in exactly the way forecast models predicted. Overnight lows are not dropping enough to allow body temperature recovery during heat events. Urban heat island effect is amplifying this in every major metropolitan area. Energy bills could soar this summer with widespread heat predicted coast to coast, and as the season progresses, El Niño will have a bigger influence on every weather pattern across the country. Let me give you the full regional breakdown of what this pattern means for each part of the country over the coming weeks. If you are in the Pacific Northwest, Washington, Oregon, northern Idaho, expect above normal heat, below normal precipitation, and elevated fire weather risk. The ridge that is baking the eastern United States will also reinforce heat in the western interior. Relative to where you should be climatologically in June and July, the outlook is running well above average. If you're in the northern plains, the Dakotas, Minnesota, Montana, you're in the most volatile zone. The boundary between the heat ridge and incoming troughs from the west will park near your region repeatedly through summer. That means alternating extreme heat events and severe weather outbreaks. Derechos are a primary concern for this corridor through June, July, and August. If you are in the Midwest, Iowa, Illinois, Indiana, Missouri, Wisconsin, Michigan, the next several weeks look increasingly active. Rainfall deficits from a dry spring in parts of this region are about to be challenged by storm cluster activity and MCS systems. NOAA CPC's 6 to 14-day outlooks are showing a wetter than average signal developing for the middle of the country. But when rainfall comes in the form of slow-moving thunderstorm complexes rather than gentle soaking rain, flooding becomes the primary concern rather than drought relief. If you are on the East Coast, Virginia, Maryland, Pennsylvania, New Jersey, New York, New England, the heat dome sitting on top of you right now is your immediate concern. The pattern through the end of June strongly favours above normal temperatures and above normal precipitation, as the active storm track keeps firing along the jet stream boundary. Thunderstorm activity will be the delivery mechanism for most of that above normal rain. If you are in Texas, Louisiana, Mississippi, Alabama, and Georgia, the Arthur story is not fully over. The remnant moisture is still circulating through the region. With Gulf water temperatures remaining above average, the next disturbance to enter the Gulf has a favourable environment to work with. NOAA's below normal Atlantic hurricane season forecast carries an important caveat. Gulf and Western Caribbean systems are a separate risk profile from the deep Atlantic, and the suppression effect of El Niño is weakest in exactly the waters where those early season systems prefer to develop. This is one of the most complex and high-impact summer weather setups I've seen in years. Not because any single event is off the charts by itself, though Arthur's flooding certainly qualified, but because of the relentless, multi-threat, season-long nature of the pattern that is now locked in. Take a moment right now and drop a comment below. Where are you watching from, and what weather threat concerns you most as we head into summer? The heat, the storms, the flood risk, or the potential for the tropics to produce something significant in the Gulf? Tell me what you're watching for. I read every single comment on this channel and I respond as often as I can. If today's video gave you information you needed, share it with someone who lives in a threatened area. One share could matter. The like button helps this channel reach more people during active weather events, when accurate information is most critical. Hit subscribe and turn on notifications so you're in the loop when I post updates, because in a pattern like this, things can change fast. Tomorrow I will be watching the progression of the Central Plains storm system very closely, along with the latest model guidance on where this heat dome starts to show any signs of weakening. I will also be checking the newest Arthur remnant data to see whether any Gulf moisture recycling is generating new convective concerns over the southeast. If you only want the tropical update, that section begins about 2/3 of the way through this video. If you only want the severe weather breakdown, that is in the first part, and if you want the full picture, the heat, the storms, the floods, the El Nino science and how it all connects, you have already watched it. Stay safe out there, stay informed, and I will see you tomorrow.